And by 2075, this factory won't need a single human to run it. You're about to see robots that mine their own materials from Martian soil, factories that build copies of themselves while you sleep, and flying vehicles assembled in 38% less gravity using resources that never touched Earth. In the next 25 minutes, you'll witness how a single assembly line in 1913 became the foundation for manufacturing entire planets. But 112 years ago, building one car took 12 brutal hours and left men broken. Today, it takes 45 seconds. So how did we get from there to a half-kilometer dome on Mars that produces 200 flying vehicles per day, automatically? Let's find out. Over the next 25 minutes, we're taking you inside the complete evolution of automotive manufacturing. First, we'll see how Henry Ford's moving assembly line cut production time by 80% and created modern industry. Then, how Tesla's AI-powered gigafactories use 300 synchronized robots to build a car every 45 seconds with near-zero human input. And finally, how Tesla will manufacture autonomous flying vehicles on Mars in 2075 using self-replicating robots, closed-loop material processing, and local resource extraction. This isn't just about cars, it's about humanity becoming a self-sustaining multi-planetary civilization. Ready? Let's go back to 1913.
1, 2, 3, lift! Hold it steady now.
In 1913, building a single Ford Model T took 12 hours and required 50 workers performing 84 separate tasks. Every engine block, weighing 450 pounds, was lifted by hand. Every wheel was rolled into position manually. Every bolt was turned with muscle power alone.
How did this happen, Johnson?
Workers destroyed their bodies for $5 a day.
You know the rules about the machinery.
Injuries were constant, progress measured in inches, not miles. Henry Ford watched this chaos and knew there had to be a better way. Then, he asked a simple question. What if the car moved instead of the workers? That question changed everything. Ford introduced the moving assembly line. Suddenly, each worker had one job: install the radiator. Move, install the radiator. Move. The car flowed past them like a river. 12 hours collapsed to 2.5. Production exploded from 82,000 cars in 1912 to 202,000 in 1914. The Model T became the first car regular people could actually afford. But Ford had no idea that 162 years later, his assembly line would be operating on another planet. Over the next 50 years, the assembly line conquered the world. Every product you can imagine, radios, refrigerators, bombers for the war effort, all built on Ford's principle of continuous flow. But it remained brutal work, dangerous, exhausting, still fundamentally dependent on human muscle. Then in 1961, everything changed again. General Motors installed Unimate, the first industrial robot in their New Jersey factory. For the first time in history, a machine could weld, lift, and position parts without human hands. The robot worked 24 hours straight, without breaks, without complaints, without injuries. But these early robots were dumb. They followed programmed instructions exactly. They couldn't adapt, couldn't learn, couldn't improve. Not yet, anyway. By the 1980s, factories looked genuinely futuristic. Toyota perfected just-in-time manufacturing. Parts arrived exactly when needed, eliminating massive warehouses. Robotic arms multiplied across factory floors. Computer systems controlled temperature, timing, quality checks.
Control room here. Cut the flow to reactor 2 immediately.
A complete car rolled off the line every 60 seconds. Ford's 12 hours had become 1 minute. But humans remained essential. They made decisions, fixed problems, adapted to unexpected situations.
We need maintenance down at line 3. The robot's jammed.
The robots were powerful tools, but they were still just tools. Until one company decided robots should be more than tools. Fast forward to 2024, Tesla's Gigafactory in Austin, Texas. 5.3 million square feet, larger than 100 football fields combined. Right now, somewhere inside this building, a complete Tesla Model Y will roll off the production line. 45 seconds from now, another one. And 45 seconds after that. Again and again, 24 hours a day, 365 days a year. This is the pinnacle of Earth-based manufacturing. Or is it? Meet the workforce. These aren't your grandfather's factory robots, those clumsy mechanical arms that welded the same spot 10,000 times without variation. These machines think. They don't just follow programmed routines anymore. They learn. They adapt. They optimize themselves every single second. Every weld, every movement, every decision gets analyzed by artificial intelligence in real time, compared against billions of previous operations. Watch this robot, Station 7, the underbody welder. It just identified a more efficient welding pattern that reduces cycle time by 0.8 seconds, updated its own programming, tested the new approach, and implemented the change. Total time elapsed, 12 seconds. No human input required. No engineer wrote that code. Now multiply that by 300 robots, all learning simultaneously, all sharing knowledge across the network instantaneously. Robot 7 discovers something. Within milliseconds, robots 8 through 300 know it too. They're not individual machines. They're nodes in a distributed intelligence. The result? Tesla produces more vehicles with fewer human workers than any factory in history. Output per human employee: 57 cars per year, 5 times the industry average. Impressive, right? But these robots still need humans to manage them, to set strategic objectives, to handle exceptions the AI hasn't seen before. On Mars, they won't. On Mars, exceptions become data, and data becomes learning. Let's follow one Model Y from start to finish. We have exactly 45 seconds. Second 0 through 10. Robotic press stamps the body panels with 4,000 tons of pressure. Perfect precision, 0 variance. Second 10 through 20. Battery pack, weighing 200 pounds, slides into position from below. Magnetic alignment locks it perfectly. No bolts needed. Second 20 through 30. Dual electric motors slip into their mounts. Automated systems immediately test functionality. Second 30 through 40. Interior components install simultaneously. Seats, dashboard, steering wheel, touchscreens, all positioned by precision robots working in perfect choreography. Second, 40 through 45. AI vision systems scan every surface for defects using multispectral cameras. Pass rate, 99.7%. Welcome to the control room, the brain of the factory. This isn't just a manufacturing facility anymore. It's a learning organism. Every second, artificial intelligence analyzes 10,000 data points. Temperature sensors, speed monitors, quality metrics, energy consumption patterns. Watch this. The AI just detected a 0.3% efficiency drop at Station 12. 3 seconds later, that robot adjusted its operating speed. Problem solved before any human even knew it existed. This is the neural network controlling the entire factory. 300 robots, 50 workstations, 1 distributed mind. Last year, this factory produced 400,000 vehicles. This year, with identical equipment, it will produce 550,000. Same robots, same building. 37% more output. How? The factory is getting smarter every single day. But there's a fundamental ceiling, a limitation that cannot be overcome on Earth. Gravity. For all its intelligence, this factory remains bound by physics. Every battery pack weighs 1,200 pounds. Even the strongest robots strain to lift them quickly. The building itself needs massive concrete foundations to support tons of equipment pressing down relentlessly. Energy requirements are staggering. This single factory consumes as much electricity as 50,000 homes. And everything, steel, lithium, cobalt, aluminum, must be mined elsewhere, processed elsewhere, shipped here. Thousands of trucks, freight trains, container ships, all burning fuel, all constrained by Earth's finite resources and fragile logistics chains. Elon Musk looked at these limitations and realized something profound. Earth isn't the future of manufacturing. It's the past. To truly revolutionize production, you need 4 things. Zero gravity for construction techniques impossible on Earth. Unlimited solar energy with no atmosphere filtering the sun's power. Raw materials everywhere. Asteroids and planetary regolith containing everything you need. And no environmental limits, no regulations, no atmosphere to pollute. There's only one place in the solar system that offers all of that within practical reach: Mars. And in 50 years, this is where Tesla will build the autonomous flying vehicles that make humanity multiplanetary. Welcome to the future. 2075, Olympus Mons region, Mars. The largest structure humanity has ever built rises from the red dust. Half a kilometer in diameter, pressurized to Earth normal atmosphere, powered by redundant nuclear reactors and solar arrays covering 6 square kilometers. This isn't a factory, it's the birthplace of a civilization. And inside, robots are assembling vehicles that will never touch Earth. Vehicles designed specifically for Martian conditions. These aren't cars. They're the machines that will terraform a planet. Let me show you how we got here. 2045, Earth, 20 years from now. Walk onto any factory floor and the first thing you notice is the silence. No human voices, no footsteps echoing on concrete, no supervisors shouting instructions, just 500 robots moving in perfect synchronization like a mechanical ballet. The entire facility is controlled by one unified artificial intelligence. No human oversight, no human intervention, no human error. Watch this robot closely. It just detected a malfunction in Robot 247's servo motor. Without any instructions, without any requests, it's already performing the repair. Parts ordered automatically from the warehouse, delivered by autonomous drone in 90 seconds. Installed, tested, verified. Problem solved in 4 minutes. 0 downtime. Output per day, 2,000 vehicles. That's 1 defect per million components. Human workers on the floor, 0. But humans are still here. You can see them in the glass observation booth above. They're not workers anymore. They're architects, designers, dreamers. They design what to build. The AI figures out how to build it. They set goals. The AI determines the optimal path. This factory runs itself perfectly on Earth. But to run itself on Mars, millions of kilometers from spare parts and technical support, requires something even more advanced. It requires true autonomy. 2065. The first manufacturing payload lands on Mars. But it's not just equipment being delivered. It's robots that can build the factory itself. Robots designed to work in near vacuum, in -80-degree cold, in dust storms that would shred any Earth machine. For 6 months, 50 construction robots work continuously. No sleep, no breaks, no shifts. They mine Martian regolith and process it into concrete using indigenous iron oxide as binding agent. They extract iron directly from the red soil using magnetic separation. They 3D print structural walls 80 centimeters thick using layer-by-layer deposition. Slowly, the dome takes shape. 2066. The dome is complete. Pressurization sequence begins. Atmospheric processors pump in oxygen and nitrogen extracted from Martian ice deposits and atmosphere. Heating systems raise internal temperature to 20 degrees Celsius. Solar panels and nuclear reactors provide 50 megawatts of continuous power, 10 times what the factory will initially need, but designed for expansion. The first Mars factory is ready. Day 1 of operations, 3 vehicles. But here's where everything changes. The Mars factory learns faster than any Earth factory ever could. Why? Because the rules are different. 38% less gravity means robots can move 40% faster without stability issues. Components that weigh 1,200 pounds on Earth weigh 456 pounds here. No atmosphere means no weather delays, no humidity affecting electronics, no corrosion. 24-hour solar power during summer months means no downtime, no waiting for Earth to rotate. And the AI has one objective: optimize. By day 30, 50 vehicles per day. By day 60, 100 vehicles per day. By day 90, 200 vehicles per day. The AI isn't just building vehicles anymore, it's building better versions of itself. Watch what happens next. The robots are redesigning the assembly line, moving equipment, reconfiguring workflows, testing new sequences. No human engineer planned this. The AI identified a 20% efficiency gain and implemented it autonomously. Reconfiguration complete in 18 hours. And here's where it gets truly revolutionary. Look outside the dome. Robots are mining the Martian surface. They're not waiting for supply ships from Earth. They're extracting iron from regolith using electrolysis. They're harvesting water from subsurface ice deposits, water split into hydrogen for fuel and oxygen for breathing. They're capturing carbon dioxide directly from the atmosphere and converting it into carbon fiber composites. This factory doesn't need Earth. It's a closed-loop system. By 2075, this single factory has produced 50,000 autonomous flying vehicles, specifically engineered for Mars' unique environment from the ground up. Let me show you how one gets built. The structure starts with carbon fiber composites created from atmospheric CO2, captured, compressed, processed into raw feedstock, then woven into sheets stronger than steel at 1/5 the weight. Robotic arms lay up 47 layers in precise orientations, creating a monocoque chassis that's simultaneously the vehicle body, the pressure vessel, and the structural frame. In Earth's gravity, this would be impossible, too delicate. But at 0.38 g, it works perfectly. The propulsion system uses electric ducted fans, 8 of them, arranged in a quadcopter configuration but scaled for passenger transport. Each fan is 1.2 meters in diameter, powered by motors producing 85 kilowatts at 12,000 RPM. In Mars' thin atmosphere, just 0.6% of Earth's density, these fans would be useless. But they're not designed for Earth. The blade geometry is optimized for low-pressure environments, spinning faster, moving more volume. Vertical takeoff and landing capability. Range, 800 kilometers on a single charge, enough to cross from Olympus Mons to Valles Marineris.
Still can't get over the view.
I know, right?
Passenger capacity, 6 humans in a pressurized cabin maintaining 0.8 atmospheres. Top speed, 400 kilometers per hour. Faster than any aircraft could safely fly in Mars's thin air without specialized design. Energy storage uses solid-state batteries manufactured from lithium, extracted from Martian brines, silicon from regolith, and proprietary electrolyte formulations developed by the factory AI. Energy density, 850 watt-hours per kilogram, twice what Earth's best batteries achieved in 2024. The battery pack doubles as structural reinforcement integrated into the floor of the cabin. Charging time, 45 minutes at a solar-powered station, or 8 hours from the vehicle's own fold-out panels during daylight. The avionics run on radiation-hardened processors, necessary because Mars's thin atmosphere provides minimal protection from cosmic rays. Autonomous flight AI handles navigation, obstacle avoidance, weather prediction, and emergency landing site selection. No pilot required, though manual override remains available. This factory used those 50,000 vehicles to build 5 more factories, robots and materials transported in the cargo variants, construction managed by the central AI network. Each new factory dome constructed by vehicles and robots produced here. Assembly time per new factory, 8 months from first groundbreaking to first vehicle produced. And now all 6 factories are producing vehicles and robots simultaneously, their outputs coordinated, their learning shared. 50,000 vehicles seems impressive, but what if one factory could build another factory completely autonomously with no human input whatsoever, improving the design with each iteration? But there's one more level, one more transformation that recontextualizes everything. Something impossible is approaching. 2125. Look at Earth from space. But this isn't the Earth you know. An orbital ring encircles the planet at 42,000 kilometers altitude, geosynchronous orbit, built entirely by self-replicating space factories over 15 years. The ring is 200 meters wide, 50 meters tall, and extends completely around Earth's equator. And inside that ring is the largest manufacturing facility ever conceived. Not just larger than any country, not just larger than a continent. This factory has more internal surface area than all of Earth's landmasses combined, 4 billion square meters of production space. And it's building something that would have seemed like pure fantasy just 150 years ago. Generation ships, interstellar vessels designed to travel to other star systems over journeys lasting 1,000 years. Each ship is 5 kilometers long, 1 kilometer in diameter, spinning for artificial gravity, shielded against cosmic radiation by 10 meters of water and regolith. Life support systems that recycle everything indefinitely. Each ship carries 50,000 humans, an entire city in space. Manufacturing facilities so the ship can build anything it needs during the millennium-long voyage. Terraforming equipment ready to transform whatever world they find. Seeds for every plant species, genetic libraries for every animal, the complete knowledge base of human civilization stored in quantum crystals. Everything needed to start a new branch of humanity on a new world orbiting a distant star. Right now, in this moment, 100 of these generation ships are under construction. In 2130, they launch. Destination: Alpha Centauri, 4.37 light-years away. Tau Ceti, 11.9 light-years distant. TRAPPIST-1, 40 light-years away, with 7 potentially habitable planets. We started with Henry Ford making one car in 12 hours, each component installed by hand. 212 years later, we're building planet-sized factories that manufacture the vehicles to spread humanity across the galaxy. That's not evolution, that's transcendence. So here's what this really means. In 1913, Henry Ford revolutionized manufacturing with one insight: move the car, not the workers. That insight led to mass production. Mass production led to automation. Automation led to artificial intelligence and robotics. And then Tesla took that same assembly line logic, scaled it through software, sensors, and AI, and pushed it beyond Earth. First into gigafactories, then into off-world manufacturing. AI and robotics led to Mars. Mars led to self-replicating factories. Self-replication led to post-scarcity. Post-scarcity led to the stars. Your children will grow up in a civilization that builds habitable planets the way we build cars. Systematically, efficiently, routinely. We went from 12 hours to build one car to building factories that create entire worlds while you sleep. That happened in 200 years. What happens in the next 200? If this journey from Ford's assembly line to Tesla's generation ships got you thinking differently about humanity's future, hit that subscribe button. Now I want to hear from you. What future factory should we go inside next? A city-sized robot shipyard? A deep ocean materials lab? A mega factory on the moon? Something even crazier? Drop your best idea in the comments and tell me what you want to learn, see, and experience. Until then, remember, the impossible is just the future we have not built yet. This is Future Factories, and we'll see you in the future.